Okay, so the next lecture is the distributions. Okay, so we are discussing the distributions. After the distribution, parametric and non-parametric, and then we will start the linear regression. So what is distribution here and why it is required in the data science? See, so from a practical perspective, we can think of a distribution as a function. We can think of this as a function, okay, that describes the relationship between the observations. So it is just a function that describes the relationship. So if I talk about anything, suppose we are having this table, okay, and this table is representing something like the e, or you can say the age and the height. So there might be exist some relationship between the age and the height. So suppose age is 1 year, then height, there is some height, age is 2 year, then some height, age is 3 year, then some height. So this is a data, and some before thought that this data or this distribution is following a function. We do not know which function exactly it is. Okay. So from a practical perspective, we can think of a distribution as a function that describes the relationship between observations. Okay. So a distribution is simply a collection of data, okay, a collections of data, and usually arranged in order from smallest to largest, but it is not exactly every time. Okay, but it is just a collection of data, and we thought that it might be following a some kind of a function. Okay, so it is just a relationship between the observations. And in data science, the distributions are not limited. We can't say there is a one kind of distribution or there is a two kind of distribution. Okay, so there are a lot of distributions are available in the data analysis, or you can say the statics. Okay. So once a distribution function is known, it can be used as a shorthand for describing and calculating related quantities. See, if we know the functions, what we can do using that function? What we can do if we know that function? Uh, uh, See, if distribution function is known to us, then what is the benefit of it? If we know the distribution function, what is the benefit of it? First, the benefit is we can visualize. We can visualize our data. Okay, so we can visualize our data. Okay, and we can also calculate the likelihood of something. Suppose you are having some data. Okay, something is given to us, and something is this is question mark. Sorry, this is given and this is question mark. Okay, and somebody this is given for this given for this given for this, and this given, and this is question mark. So if we know the distribution function, or you can say if the observation function is known to us, then we can visualize this data using some plotting, and also we can calculate the likelihood of the observations. Likelihood of the observations. Okay, I will show you one research paper as well where this distribution is used. I will show you, but not exactly. I will show you the distribution. I will show you how they have just used that. Okay, so distribution, it is clear. It is just a kind of a function. Okay, we can think of distribution as a function that describe the relationship between observations in a sample space. Okay, it describes the relationship. or you can say the distribution is a collection of data. I will show you the example as well in my consecutive pages or slides. Okay, so it is just a kind of collection of data. Okay. So what is the advantage of this? It will be used for visualizing the data, or you can say the plotting the relationship between the observations, and also in calculating the likelihood of the observations. Okay. It is clear?
Yes, sir.
And if you know, anyone know Gaussian distribution? It is the most widely used distribution in data science. Okay. So I
Sir,
will give
the method, but I forgot the formula and
oh, so I will give you the example of the Gaussian distribution. Okay. And in your syllabus, we are not supposed to learn all kind of distributions. So I will give you the example of Gaussian because it is widely used. Okay. So now there comes a density function. See, so see here we thought here we see it is some kind of a functions. Okay. So now we are discussing the density function, and based on that density function, we will discuss a particular kind of distribution. See, it is clear why we are discussing the density function, because we can think of distribution as a function. Okay. Which kind of function? It can be anything. So we are discussing the density function, and based on the density function, there are two kind of probability distribution. Uh, um, okay. So density function, what is density function? Density functions are the function that describe the proportion of data or likelihood of the proportion of observation change over the range of distribution. It will not be clear using this definition, it will be clear using the example. Okay. Definition is just to for the notes purpose and for the exam purpose, but I will clear the things using the example. See, so density function are the functions that describe the proportion or likelihood of the proportion of observation that change over the distribution. So there are two kind of distribution function. First one is the probability. First one is the probability, and second one is the cumulative. Any one of you heard about any one of them? Probability density function and cumulative density function?
no, sir.
No. Okay. So I will discuss the probability density function. We call them PDF. Okay? And cumulative density function, we call them CDF. Okay. Or most widely we will use the Gaussian PDF, and then we will use Gaussian CDF. Okay. But there are other kind of probability density function as well, just like students T score, students T. And one more thing I remember is the chi-square distribution. Chi-square distribution. Okay. So these again follow these kind of a probability density function and the cumulative density function. One more distribution is there, Bernoulli distribution. Bernoulli distribution. Again, two categories are there. Okay. And Bernoulli, I think binomial distribution are also there. Binomial. One more is exponential. So a lot of distributions are there. Okay. But our goal is to understand the distribution, and the most widely is the Gaussian. So we will discuss. Clear? So we will discuss these two. ठीक है, and the example then Gaussian PDF and Gaussian CDF. ठीक है, so see probability density function, it calculates the probability of observing a given value. ठीक है, so it is based on the calculating the probability of observing a given value. ठीक है, so I have one example. Hmm. Suppose we are having this function, uh, f of x is equals to 0.048x bracket 5 minus x. ठीक है, verify that f is a probability density function. So for see, it is a probability, so probability can be negative or not.
Can you repeat your question, sir?
uh, the question देखो, we are discussing the probability density function. ठीक है, so probability density function is based on calculating the probability of observation. Now the question is, we are having a function f of x is equals to 0.04x bracket 5 minus x. At the start of the lecture I told you the distribution is some kind of a function. Okay. So this is a function. Now question is verify that f is a probability density function. So it is give, we need to verify that it is a probability density function or not. So first thing came in my mind is that if it is a probability density function, then can fx be negative?
No, sir.
No. ठीक है, fx cannot be negative. ठीक है, so using that property we will verify. So if fx is not negative, then this x must have some range, I think.
Yes, sir.
है ना? So what will be the range of x? I think x cannot be greater than 5, and
Yes, sir.
x
Will be
and
the maximum value.
and x cannot be less than 0 as well.
Yes, sir.
So for a probability density function, f of x should be greater than 0, or you can say greater than equals to 0. So x is this. Okay. Now one more thing is that over integration of f of x over the interval, or you can say over the domain, must be equals to 1 for a probability density function, because it is a probability density function. So what is the property of probability? Sum of all the probability must be equals to 1. Yes or no?
Yes, sir.
है ना? So first we just drive this. This is the property. Based on that property, this one, and this is again the probability. Sum of all the probability must be equals to 1. Okay, so we will solve this. So what is our function? 0.04x 5 minus x integration. So what will be the integration of this? 0.04, okay, and it is 5x square upon 2 minus x cube upon 3, 0 to 5. This is the integration. I think all of you know the integrations.
Sir, we have not studied integration yet.
Okay, just a minute, no problem. I will tell you. Okay, just a minute. If you are not familiar, then no problem. Hmm. Okay, just it is 0.048. Okay. So see, first see, our function is 0.048 bracket x minus, sorry क्या था, 5 minus x आई थी है ना,
Yes, sir. 5 minus x.
x 5 minus x. ठीक है, so we will just write this 0.048 constant and the variables. It is 5x minus x square. ठीक है, the integration of x to the power n is equals to integration of x to the power n plus 1, okay, upon n plus 1. ठीक है, you just remember this thing. Okay, so if we are going to integrate this, I will tell you 0 to 5 after that. So what will be the constant remain outside? Okay, so 0.048, and this is 5. It is x to the power 1, so it will become x to the power 2 upon 2, minus it will become x to the power 3 upon 3. Am I right?
Yes, sir.
Okay. Okay. So this will be your integration. Now it is 0 to 5. What does it means? It means first we will keep value as a 5 equals 0. First we will keep 5. So it is 5 into 5 square upon 2 minus 5 cube upon 3 comes in the bracket minus. Now we will keep value as a 0. So it will be 5 into 0 square upon 2 minus 0 to the power 3 upon 3. Bracket close. Okay. So we will calculate this one. So it is 5 square is 25 into 5. It is 125. 125 upon 2. Am I right?
Sir, I
Mine.
have one doubt.
Yes, yes.
Sir, in place of x, why have we kept a 5 over here?
Because integration is given from 0 to 5, so it is a definite integration. It is given 0 to 5, so that means x can have value from 0 to 5.
Okay, sir.
Okay. So in place of definite integrals, first we will take, keep the upper bound, that is 5, calculate the value, then minus put the lower bound. It is called the lower bound and the upper bound. Okay. If I will talk about the definition of integration, integration is just the summation of all the small pieces. Okay. So don't go over the definition. Don't go over the definition. Just say simply the integration of x to the power n is equals to x to the power n plus 1 upon n plus 1. Okay. If it is definite, suppose 0 to 5. So एक बार बस क्या करना है, एक बार put the value 5, then minus put the value 0. That means upper bound minus lower bound. Okay, so it is 5 into 5 square, that is 5 into 25, that is 125 upon 2, minus 5 to the power 3 upon 3, that is 125 upon 3. Okay, and the next one is the is 0 है, 0. Okay, and the multiplication is 0.048. So इसको whenever you will solve this, you will have this. It is 125 upon 6. Just cross check. Cancel out this 0.008. ठीक है, just multiply it 1. You can see it is coming 1. If it is coming 1, that means yes, it is a probability density function. Clear?
Yes, sir.
Okay. So how to verify whether it is a probability density function? Just integrate that function. ठीक है, integrate that function from the lower limit to upper limit, and lower limit will be and upper limit will be decided based on the values of this x. ठीक है, so I have written this here. ठीक है, so the first question is clear. See, first question comes in our mind is any kind of function. ठीक है, second questions comes in our mind is the probability density functions. So just verify whether it is a probability density function or not. Why we are studying? They will be used in predicting the likelihood of observation, as well as some kind of plotting or visualization. Okay. So I will give you the Python example as well, that will show you the some kind of plotting of your data. Okay. So the first question is clear. Verify that f is a probability density function. Okay. I can note down here the formula for the integration if you are not aware. I will keep this. Okay. This I will keep. Okay. The next question is the what is the probability that x is greater than 4? What is the if you remember from the Bayesian theorem, we calculated some kind of probability. Why? Based on that probability, you can decide whether it fall in a particular kind of class or not. If you remember the example, I gave you the example, I think some kind of cancer patients.
Yes, sir.
है ना? So if the probability of a person having cancer is greater than suppose 80%, so you can say this person might have cancer. Okay. Similarly, here we are also having the probability that x is greater than 4. So we need to find this probability. Okay. So just a 2-minute break and just let me know whether you feel comfortable or I need to slow down, or you have any questions in your mind, anything.
Sir, right now it's the speed is good.
Okay, okay. So the next is the probability that x is greater than 4. Okay. Okay. So the next question comes in our mind is this question. Okay. X is greater than probability that x is greater than 4. So greater than 4, that means this, or it is always less than 5. It is always less than 5. So this b will become 5. See, this b will become 5 and this a will become 4. Okay. So now need to calculate this integration instead of from 0 to 5, from 4 to 5 f of x. Okay. Simply if we do not have a function, if we have some kind of probability quotient and we have given the probability, and if question is to just find the probability of having greater than x, so what you will do? Probability of x, then probability of 4.1, probability of 4.2. I can give you this example as well. Suppose you are rolling a dice. Okay. Dice, if you are rolling a dice, so there may be probably come 1, 2, 3, 4, 5, 6. These are 6 the outcomes, am I right?
Yes, sir.
And the probability of each is, I think, 1 upon 6.
Yes, sir.
Now I will tell you what is the probability of outcome of dice is greater than 4. Greater than or equals to 4, or you can say what you will do.
Sir, we'll take the frequency from 4 to 6.
Yes, 1 upon 6 plus 1 upon 6 plus 1 upon 6. Okay. So similarly, whenever instead of this kind of table, when we have a function, then instead of the summing, we will use the integration, because the definition of integration tells us that it is the summation of the small values. Okay. In case of dice, our values are 1 to 6. These are the 1, 2, 3, 4, 5, 6. But in case of function, uh, it is not just an integer. X may be 4, then 4.0000001, 4.00002, and so on up to 5. So that's why instead of directly summing the probability, we use the integration. I think now it is clear to you. I have correlated an example that you studied in probability with this example. Clear?
Yes, sir.
Okay. So now next time we need to integrate this. Okay. So for the integration, again we are having the same things, but now the limit has changed. Okay. So we are having 4 to 5 integration of 0.048 5 minus x, or x, sorry, x is also, I think I forgot this, x is also there. X. Clear. So again, the integration is same, but the domain is changed. So 0.048 5x square upon 2, 5x square upon 2 minus x cube upon 3, 0, sorry, not 0, 4, 5. So first now you will put the lower limit. So 5 into 5 square upon 2 minus 5 cube upon 3. Okay. And the lower limit 5 into 4 square upon 2 minus 4 cube upon 3. Just calculate this and you will have this output. I think you can calculate, or I need to do calculation.
Sir, I can calculate it.
Oh, so this will be, I think,
One,
125,
one,
125 upon 6, and this will be what? It is 5 for 16, 80 upon 2, that is 40, minus 64 upon 3. Okay, so you can calculate this. Okay, so
sir, the PDF function should have the range from 0 to 1, right?
yes, probability density function, yes. Okay, so you can calculate this and we will have, I think, this output 0.014. Cross check this. Okay, so just cross check with how much it is. Maybe I
Sir,
think it is
0.104. It's
104. Okay, this one. Okay, so this is your solution here. Now the next question is, what is the probability that x is between 1 and 3? 1 and 3. So again for this, if I will take the example of dice between 1 and 3, so you just add 1 upon 6, 1 upon 6, 1 upon. Similarly, in case here also, probability of x between 1 and 3, just write here 1 lower limit, 3 upper limit, integrate, and you just have your solution. Okay, clear this one?
yes, sir. Sir, when you upload this PPT on LMS, can you like save all the working that you have done from using the pen?
Okay, I will update, save this. Save as I can do notes update. Updated. Let me check whether this automatically saved or not. Lecture 4 updated. Now I think it is saved, no?
Yes, sir.
Okay. Hmm. Okay, so I will upload this today after the class. Okay, now next is the cumulative density function. So as you learn in your statics, cumulative means suppose just a table here, suppose. Okay, here. Suppose you are having your observations here and here probability. Same take, I am taking the example of dice. 1, 2, 3, 4, 5, 6. Probability 1 upon 6, 1 upon 6 and 1 upon 6. Okay. So cumulative means the probability of observation equal or less than. That means now the probability of outcome 1, then the probability of outcome 2 or less than 2. 2 or less than 2. How much it will be?
Sir, 2 by 6.
Yes, 2 by 6. 1 upon 6 plus 1 upon 6. That is 2 by 6. Then outcome less than 3, less than or equal to 3. So the
1.
probability of 3 plus
1
the
by
probability of less than 3. Less than 3 how much? 2 upon 3. So it is 3 upon 6. Similarly, at the end, we will have 6 upon 6. That is 1. So this is called cumulative density function. So in case of cumulative density functions, if you plot the graph, it might be something like this, you can say. Not exactly we can justify, but it might be this because it is always increasing. Am I right?
Yes, sir.
It will always increase. So it might be your observations and it might be your cumulative probability. And in case of the first one that we have discussed, we can't justify whether this one or anything can have. Okay. So this is cumulative density functions. Okay, so I'm taking the example of rolling. Or do you want to see a Python file to check the visualization as well?
Sure, sir, I'll do it.
Yes, sure. Okay, so I am opening the Python file. Jupyter notebook. Okay. Hmm. See. Okay, so first thing is required for the visualization. Oh, sorry, pen will not work here. Okay, so first thing required is from matplot import pyplot for plotting. Okay, and the second one is this. Why? This will have CDF, not CDF. What is PDF? PDF and CDF. PDF stand for probability density function and CDF stand for cumulative density function. Okay. So just a minute. Okay. So you can see we have imported these libraries from matplot, lib import pyplot, from scipy.states import norm. Okay. Norm means normalization. Norms means normalization here. And I will tell you the Gaussian normalization. It is, we are talking about the Gaussian normalization. Okay. I told you in the start of the lecture there are a lot of distribution. One of them is Gaussian, Bernoulli, student, chi-square, and binomial. Okay. So, but in here we are discussing Gaussian. So this is here. Okay. So first we have taken some kind of a distributions. Any values we have taken. So this is a range function in NumPy library, in NumPy package, sorry. from numpy import arrange, and we have taken some values from -10 to +10. ठीक है, I think all of you familiar with this
Yes,
from,
sir.
ठीक है. So see, it is taking some time. Okay, so you can see it is a graph between the sample space, the sample space, and this probability density function. ठीक है, but for calculating this Gaussian probability density function in with this data, we need some kind of mean and standard deviation. So for this data, we are considering mean as a 0 and standard deviation as a 1. ठीक है, so for different kind of data we can have different kind of distributions. ठीक, I will discuss one so I will tell you one example with my research paper as well, where we have used this type of distributions. Just a minute. I think someone has suggested me if it is possible, we can show you these things in a paper as well. Okay, so it is, I think, in this. Just a minute, I am opening that one. Okay. Okay, so it is, I think, mean. Okay, you see this? Uh, we have taken normalized measurement matrix, random numbers between 0 and 1, mean 0 and standard deviation 1. The highlighted one is visible to you.
Yes, sir.
So in this research paper, I have chosen a matrix, and the value of that matrix are derived from the Gaussian normal distribution, derived from the Gaussian normal distribution. ठीक है, and the mean of that distribution is 0 and the standard deviations is 1. ठीक है, it is just an example I am showing you. Okay, in the research paper as well, I have this kind of distribution is used. So, so one of the example is to use the random matrix. ठीक है, random matrix uh, which has a 0 mean and 1 as a standard deviation. ठीक है, clear है? If you want to see that matrix, I need to run my code. ठीक है, it is okay, or you want to see that code as well? It is just a single line actually. uh, ठीक है,
Yes, sir.
it is just a single line to just design a random measurement matrix which is having 0 mean and 1 as a standard deviation. ठीक है, so similarly here also we are finding the calculating the probability density function. In the notes I will come mean and standard deviation पर I will come. ठीक है, so we are finding the probability density function. ठीक है, with some this data here, and with 0 mean and 1 deviation. You can change this as well. Suppose I am changing this 5, and you just see what will be the difference here. Okay, see this is graph here. When mean is 0 and standard deviation is 1, this is the graph. Okay, now see the graph, difference in the graph. Now you can see the difference in the graph. So the distribution also depend on the parameter mean and standard deviation as well. ठीक है, now in your mind there is a question, what is the formula to calculate this probability density function? Because we know this sample space, we know this. ठीक है, we know the mean, we know the standard deviation. Sometimes what happen, instead of taking this 5 mean, we can take a mean of sample spaces as well. ठीक है, clear na? So changing the mean and standard deviation can change your probability density function as well.
Yes, sir.
है ना? So it is just an example to just to show you graphically. Okay. So coming to our notes, before coming to, I can tell you can see means and variance are I have written here. Okay. So the example I have shown you is for the Gaussian. Okay, for the Gaussian. Okay. So example again that I try to give you is the rolling of a dice. Okay. We are rolling our dice. Okay. So probability of x 1 upon 6 for k equals to 1 to 6. That means 1 2 3 4 5 6, and the probability is again 1 upon 6 for all. Okay. Cumulative density function, if you want to calculate, I already discussed summation of the previous 1 upon 6, it is 2 upon 6, it is 1 upon 6 plus 2 upon 6, that is 3 upon 6, and so on. Okay. So just an example, this is the example है. ठीक है. Yes or no?
Yes, sir.
Now one thing is for the rolling the dice, if I will tell you the probability of the outcome 0, what will be the probability?
Sir, the probability of zero.
It must be 0 because 0 cannot come when you roll a dice. It must
Yes.
be from 0 to 6. Okay. And the probability, cumulative probability, we are talking about cumulative probability, and the probability of greater than 6.
No, sir.
Cumulative probability of greater than 6.
Sir,
Just like just like cumulative probability of 7. 7 means 7 or less than 7. Probability of 7 is 0, and cumulative probability of 6 is
zero.
cumulative probability, cumulative
Sir, one.
1. So that means whenever someone tell you to ask you a cumulative probability of an observation x greater than the upper bound, it must be equals to 1.
Yes, sir.
And just for a rolling of a dice, outcome can be 1 to 6. If someone asks you what is the probability of 7, obviously 7 cannot come, so it is 0. Cumulative probability of 7. Cumulative probability means the summation of the all the previous probability. So probability of 7 is 0 plus probability of 6 plus and so on. So it must be 1.
Yes, sir.
है ना? Yeah. So that's why this less than equals to sign stand for cumulative. Less than equals to sign stand for cumulative. Clear hai? Okay, so just 2 minute break and just let me know till now. Do you want to ask anything?
Sir, is there a general formula for a PDF, or is it always
Yes,
given
of
in question?
probability density function. I will tell you the formula for the Gaussian. For different distribution, there is a different kind of formula. Okay. For Gaussian, I will tell you the formula. This formula for the Gaussian distribution. Okay. For some kind of distribution like we can have. For Bernoulli distribution, the formula may be different. For uniform distribution, the formula will be different. For exponential, the formula will be different. For Gaussian, I will tell you the formula for the probability density function. I think you are talking about this one, this formula.
Yes, sir.
You know? So see, for the same question, I will not here, I think. See, I have taken another distribution as well, chi-square distribution. Okay. For chi-square distribution, we are having this graph. So it depends on the which kind of distribution you are using. Okay. So for different kind of distribution, different formulas are there. Okay. So I will tell you the one example of Gaussian distribution. Okay. So see, now coming to the Gaussian distribution. Clear? So first we discussed the distribution, then we discussed the function, then we discussed the one example. Now we are coming to the specific distribution, that means the Gaussian distribution. Okay. So Gaussian distribution is the focus of the most of the research field. If you see the research paper, okay. So other kinds of distributions are also they used, but the Gaussian is the main topic that we are going to discuss. And you can see it is widely used in the research. Okay. So data from many field of study is surprisingly can be described using a Gaussian distribution. Okay. So it is found that in many field the data can be described using the Gaussian distribution. Okay. Or we also call this normal distribution. If you remember our Python code, we used norm. Yes or no? Norm dot c PDF. Yes or no?
Yes, sir.
So it is just a Gaussian distribution, also called normal distribution. So that's why the Python library package in the inside the package we have a norm as a module. Okay. So Gaussian distribution can be described using two parameters. So for Gaussian distribution, we need two parameters. First parameter is the mean, and the second parameter is the variance. Okay, that's why in the Python code we used a norm dot pdf our sample data. After that we used mean. After that we use variance or standard deviation, I do not remember exactly. So we use these two things. Okay, so for Gaussian distribution we need these two parameters denoting the Greek lower letter mu. Okay, expected value of the distribution, and Greek letter lowercase sigma. So you can say this is just a sigma here, and this is mu here. I think you are familiar with these symbols, mu and sigma,
Yes, sir.
you know. Okay. So for Gaussian distribution, we need mean and variance. And again, I am repeating, for different kind of distribution, you may need different kind of parameters. Okay, this is for Gaussian distribution, mean and variance. Okay. So, and this is the formula that you were asking to me. This is the formula for the Gaussian distribution. So Gaussian probability density function, probability cumulative. Just what is cumulative? Cumulative is just the summation of all the values. So for cumulative, we just need to integrate this. Okay. So
Sir, I have a question.
no, no, we are not. I'm not telling you any question. I'm just discussing uh, Gaussian distribution.
No, no, sir, I have a doubt.
Yes, 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 yes. Please ask. Please ask.
Sir, in question, like suppose in the question one, we were given the sample PDF function to calculate. So do we have to use this formula in the question every time to calculate that to get that function, or will it be given in the question?
No, no, it will be given to you. It will be given to
Okay,
you if we are asking some this type of questions.
okay, sir.
Okay, the probability density function will be given to you. Okay, so that was the general. That example was the general. Okay, now this is specific. This is for Gaussian. ठीक है and why Gaussian? Because it is found that a lot of kind of data follow Gaussian distribution. It is found that if I will tell you the example of rolling dice is itself, if you roll a dice multiple times and if you plot the graph, you will see it will follow this pattern, this kind of pattern it will follow. If you roll a dice multiple times, one time you can roll, then two times just roll it, then three times just roll it and plot the probability. And if you see that the graph and this graph look almost same, not exactly but almost same. Okay, so you can visualize that as well. Okay, so this graph I have already discussed from here. this one. Okay, so 0 mean one standard deviation and any kind of data a range minus 10 to 10 0.01. Or I think you might be familiar with the a range function. Yes or no?
Yes, sir.
And a written evenly spaced value within a given interval. Okay, so we have taken interval minus 10 to 10, or we can see the sample spaced as well. So you can see this event. Okay, ठीक है. So now the next is क्या था? Okay, this is clear. ठीक है. Now now after the probability density function, we have a cumulative density function. ठीक है. This is I think CDF. ठीक है. PDF we have already discussed above. ठीक है. This one. Okay, so just I want to know whether you want slides as a class discussion or this Word file, because uh, if I will keep my content in these slides and if I will upload that for you, then what I am telling, it is very difficult to write all the content in these slides. So which one is you prefer most?
Sir, this one is this the PDF that from you which you are teaching right now is better for
Okay,
us.
okay, 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 okay. Because I saw many faculty used PPT, so I just ask, matlab, it is habit for you as well, or this is okay? Okay, it is just like offline classes. I'm preparing my handwritten notes, so now this time in the online mode, instead of handwritten, I'm just writing on the Word file. ठीक है. So now for the cumulative density function, it is just we need to integrate. ठीक है. बस. So these are the properties cumulative density function. ठीक है. uh, I think you might not be familiar with this term limit extends to infinity. Am I right?
Sir, we had studied about limit in second semester, but it's been quite a
Okay,
while, so we
no
forgot.
problem. You just keep in mind. First property what? First property means all the probabilities are 0 to 1. Am I right?
Yes, sir.
ठीक है. In the above I told you rolling a dice, what is the probability of outcome less than 1? It was 0.
Yes, sir. Zero.
But same thing is here. Same thing is here. मतलब less than 0, less than 1 means it can be 0, it can be minus 1, it can be minus 2, it can be minus infinity as well.
Yes, sir.
ठीक है. If you remember the ruling of dice outcome 6 cumulative density function, 1. Same thing is here. Four things I told you, it will always increase. Yes or no? It's not
Yes,
this one.
CDF had a positive graph.
Yeah, so it is not decreasing. You just you can read the difference between the increasing and non-decreasing, because it is a non-decreasing. Non-decreasing just a kind of increasing, but in increasing two value can be same, but here they can't. Okay, so it is non-decreasing. You just okay. So for the same data, I will tell you for the same data. Okay, so this is the uh, again the same data, same library data, and this is the CDF cumulative density function, and we are plotting them. So this is the graph here. ठीक है? This is the graph. This is fine.
Yes, sir.
ठीक है. But एक चीज keep in mind in this, if the data has been generated from a normal distribution, so for cumulative density function the data must be generated from normal distributions. ठीक है. So this is again I have plotted the graph of students t distributions. but in your syllabus it is given only the distribution. They didn't specify what kind of distributions. Okay. So Gaussian is widely used. That's why I used Gaussian distributions. Okay. Oh, I think I have another class. Oh, sorry. At 9:30. Sorry. Oh, can we leave now?
Okay, sir.
Okay. Stop recording.